Hey everyone, Eric here. Today I want to cover our top 6 most asked questions through customer service. This is the stuff we get almost daily, if not hourly, so thought it would help to answer some of the common questions, and I'm just going to jump right into it. The number one question we get after somebody buys a battery is, what type of charger should I use to charge my battery with? So there's typically lead acid with AGM mode, and then lithium, which is obviously the preferred type of charger. We actually sell lithium chargers. These are specific to our batteries, or to lithium batteries, or lithium iron phosphate. Then you'll find stuff out there like these, which do DC, and they say they'll also do lithium. If you understand the voltages, and I'd like to explain that, it'll make a little more sense as to why each works or doesn't work with lithium batteries. So a typical lead acid battery will charge in the high 13 range. It might go a little bit above that, but it'll drop back down pretty quickly. And the lithium ions, to move across the membrane inside of the battery, really need at least 13.5 volts to start moving stuff. And the higher the voltage, the better they move, but there's a limit to how high you can go. And so that's why most people will say between 14.2 and 14.6 for lithium iron phosphate batteries. So that kind of makes sense why lead acid charger wouldn't work very well with a lithium battery. So why do some people say, well, you can do it if it has AGM mode? Well, AGM is a type of lead acid battery, but it requires a higher voltage to get the electrons moving into the battery for those. And so that higher voltage is usually around 14.2 or 14.4. And so that's why you can charge with these batteries. There's a caveat to AGM though, because sometimes the AGMs will have time limits on them. So they'll say they'll have a max of a 4-hour charge cycle at that higher voltage, and then they may either just stop or they may cut off. Different mileage with different types of chargers, so it's not really a one size fits all. Different manufacturers will do different things. So the answer to what kind of charger should I use is, you want to be using a lithium iron phosphate specific charger between 14.2 and 14.6. After that, you can get away with an AGM charger. It's kind of a temporary thing. Unless it works really well for you and you're not having any issues, plan to upgrade to a lithium charger eventually. And then lead acid, don't even try it. It's a waste of time. You're not going to get above about 20 to 30% on the charge, and it's going to take days to get there. So there you go. That's question number one. Number two, how can I charge from my vehicle? This is a very common question, usually right after what kind of charger do you recommend. How can I charge from my vehicle? So this applies to campers, vans, travel trailers, things like that. They want to put a lithium battery on there. They want to be able to charge from their vehicle. Makes sense. You're driving down the road. You want to be able to charge up because you know that alternator is running and it can charge the lead acid. Why can't it charge this? So you have an alternator that's pushing out power, amps, and then you have your battery over here absorbing. The problem is the lithium will take all the amps that the alternator can send. So if you have, say, a 100 amp alternator, it's gonna take all 100 amps and send it to the battery. So what that does is it prematurely burns up the alternator. And what you want to do is put something in between there, like a DC to DC charger. That's the keyword search term you want to be looking for, is DC to DC charger. This is kind of a knockoff of a Renogy we were evaluating as a potential product to carry. The whole thing fell apart kind of with the supplier, but that's another story. Anyway, this is a 20 amp DC to DC charger. They work pretty well, and if you've ever seen a Renogy, you can tell this is almost identical except for the shape. But the way it works is you put the alternator up over on this side, positive and a negative, pretty simple. This restricts the flow of electrons to 20 amps, would be a good way to say it. So this will prevent pulling more than 20 amps from the alternator, and then it just sends it out on this side. Of course, you got some dip switches if you want to go lead acid or lithium. And so power out to the battery and you're good to go. You won't burn up your alternator prematurely. Okay, question number three we get a lot is, what settings should I use for bulk, absorb, and flow? And like I explained earlier, it's a voltage thing, 14.2 to 14.6. It's just kind of where the electrons like to, the ions flowing across the membrane inside of the actual lithium cells. That voltage range of 14.2 to 14.6 is kind of the sweet spot. Anywhere in there will be fine. If a lot of people will say, no, give me a specific number. I'll just say 14.4. I think that's the default for most Victron equipment, but really anywhere in that range is going to be fine. If you have a default of 14.3, and it's going to be a big pain to adjust that or change it, just leave it 14.3. It's in that range and you're going to be fine. And then for absorb and float, kind of the same. Absorb, say 13.8, plus or minus like 0.1. The idea there is that you're dropping the voltage down so that you can get a little bit more at the end, because when you're ramming voltage, high current, the cells are going to spike up on their charge curve a lot faster. So this is a typical charge curve for a lithium cell. And when you get over here to the end, if you got a high voltage, high current going in, it's going to shoot up a lot quicker on here. But if you go to absorb, it's going to slow down, and you're going to get a little bit further over into the 100% or more range. So that's kind of the reason why you want to drop that voltage. So 13.8 plus or minus 0.1 doesn't have to be exact, somewhere in that ballpark. And then for float, same thing. You're just trying to keep it over here on this far end. So 13.6 should work fine. You can really deep dive on that and go research some more, but those are the settings. 14.2 to 14.6 on the bulk, 13.8 for the float, or for the absorb, and then 13.6 for the float. So there you go. All right, question number 4. Why did I lose percentage overnight? This is a pretty common question. Maybe once or twice a week we get it. And so I've got some, that's kind of why I drew these up here, to kind of help explain that. So inside of the BMS, and this is a BMS, this is a damaged one, so I just have it for demonstration purpose to kind of, training aid. Inside of the BMS, there's firmware, and inside of that firmware, there's parameters that are set, and 100% inside of there is set at 3,400 millivolts. And so you can see, I'll explain this real quick. This is a charge curve for a lithium iron phosphate battery. You got 2 volts over here up to 4 volts. That's the minimum and the maximum for a battery. Below 2 volts, you'll damage it. Above 4 volts, you're going to start having some catching fire type issues and damage issues. So 4 and 2. And so the sweet spot, well, and then I'll cover the axis here, 0 to 100%. So the capacity is tied very closely to the voltage, and so that comes into play over here. Capacity is tied in closely with voltage, and you can see that. Typically, you'll see about 3 volts, and so we say inside of the BMS that 3 volts is kind of the bottom end. Once you get below 3 volts, the charge drops off so fast that there's very little capacity in there. Maybe 1 to 2% below 3 volts worth of capacity. And then same on the top end. Between 3 and 3.4 volts is where most of the capacity lies. Once you hit 3.4 volts and you shoot up from there, maybe 1 to 2% beyond 3.4 volts. And so most people say no more than about 3.65, and that's probably somewhere around here. This really isn't to scale, but 3.65 is where most people say don't go any more than. And that's what's set in our BMS as the single cell over voltage cutoff. And so that's under the alarm you'll see when the battery is full. You'll see single cell over voltage, and that just means that the battery is full. It means inside of the battery there's 4 cells. There's 4 of these, and each one of them follow a curve like this. And anytime one of them reaches 3.65, the BMS shuts off the charge path and doesn't allow any more charging. And then on the backside, when it drops down to, I believe it's set for 2.5 volts, it cuts off discharging so that you can't discharge it any further. So that explains the charge curve for a lithium iron phosphate cell. Now let's talk about why you lose percentage after. So you charge all day, you go to bed, and it's at 100%, and charging got cut off because it hit that high voltage there on one of the cells. And you wake up in the morning and it says 90%. You're like, well, what? How did I lose 10% overnight? So what happens is when it hits that 3.65, the voltage is increased a little higher than where it settles out at, because of when you're charging a battery, the voltage just shoots up, and when you're pulling a draw on a battery, the voltage is always going to sag a little bit. So, and then when you take away the load or you take away the charge, it's going to go in the opposite direction a little bit. It's called settling. Batteries are just going to settle. So it hits that 3.65, and maybe this cell didn't quite get up there. Maybe cell number 1 went all the way up to 3.65, and then cell number 2 only made it up to 3.55. They're not perfectly top balanced. I'll talk about that in a minute. But let's say the second battery didn't quite make it all the way. Well, then when they settle out, cell number 2 drops down to maybe 33.75, and cell number 1 settles out at, say, 34.10. So the BMS is trying to figure, just based on the millivolts of each individual cell, what's the overall capacity. And it may, it may drop that percentage based on the 4 average voltages, might be just below 3400, and so it'll come across as you lost some capacity. In reality, you didn't. You're beyond that kind of threshold of what's considered 100% full. So I still had customers come back and say, no, I don't believe that. It shouldn't be saying 90%. I don't believe that. I try to explain to them, you really need to look at the voltages. Anything over 13.35, and you're beyond, you're at this point, it's called the knee. You're past the knee, just barely past the knee, or right at the knee, and you're not going to get but maybe 1 or 2% more in there, even if all the cells were perfectly balanced and they all went up to 3.65 exactly, and you hit that 14.6 volts and you nailed it on the head, perfectly balanced. You still only are going to add maybe 2% from 13.35 to 14.6. You're only adding a couple of percentage, a couple of 1 to 2% capacity. So why is that not a big deal? Well, so these are 104 amp hour cells. We actually derate our batteries, and a lot of companies will do this. They'll put 103 to 105 amp hour cells in a 100 amp hour battery. And so even at 95%, or in that ballpark, you're still going to be at 100 amp hours of capacity in the battery. So there's a little bit of reading between the lines there, I guess you could say. And because you can see it in the BMS, it opens up a whole nother can of worms with customer support and people seeing these red marks and these different things. And I've had a lot of customers say the battery performs perfectly. I just don't understand what's going on and why I'm seeing these different things. So I'm hoping this is going to help shed some light on it. There's a lot of really good articles and tutorials out there, and people that have made better videos than me about this stuff. If you want to go watch it and try to maybe figure that out, I encourage that. I will say one more thing, that the customers that are like, man, I'm not sure I believe you. I say, well, look, do a quick equation, or do a quick test for me, and if it doesn't work out, I'll refund your money. I'll take the battery back, no problem. And that is amps times time equals your amp hours. And so if you put a 10 amp load on this 100 amp hour battery for 10 hours, you should be able to run it the whole time. And so what that means is 10 amps times 10 hours is 10 amp hours. I'm sorry, 10 amps times 10 hours is 100 amp hours. You should be getting 100 amp hours out of the battery. And so that's kind of a test. Just put a 10 amp load on it and see how long it lasts. Make sure it's fully charged first. Put a 10 amp load on it and see how long it lasts. And then if you got a 200 amp hour battery, it should still be kicking after 20 hours. And so it's just kind of a thing. What we do, and we spot check our batteries when they come in from our suppliers, we have something like this, which does all that for you. You basically just plug it in, turn it on. It's got a little heating element under here that the fan keeps cool, and it does a measurement. And so we can tell, typically on a 1,200 watt hour battery, we're getting usually a little over 1,300 watt hours. So we spot check them when they come in, and I can pretty much guarantee you they all have the rated capacity, even though the app sometimes might say, after settling out 85% or 90%. I agree, it looks alarming, but if you want, I'll take it a step further, and I know this is getting a bit long, but you can also edit these parameters inside of the app if you want. Through iOS, I think the third-party developer charges like a $6 fee to upgrade the app so you can edit these parameters. If you wanted to lower this to like 3370 and then lower 80% to 3340, you can totally do that, and I'll show you how here in the app. It's actually pretty simple. I dropped the battery on this phone recently, so please bear with me. But let's see, we'll go back. So inside of the battery here, we can see we're 100%, 13.3 volts. I don't know if you saw that on the bottom right screen. You click config, and then you click the second tab for BMS settings. You do BMS read, clear that, and now it's actually reading the parameters that are these parameters. It's reading these off of the BMS inside of there. And if you want, you can see right, I don't know if you can see it, but it's cell full voltage is set to 3400. So if we wanted, we could just change that. We could do this, and we could say 3370. It's still going to say full, but so I hope that helps and makes sense. The point is, you can edit some of these parameters if you want. If you just want to see 100%, these are just readings only. That's not actually going to change anything of the performance of the battery. If you change these capacities, it's just what you see as 100%. Like, you're not changing the actual available energy in the battery. You're just changing that little meter that says what the percentage is. And so you can tweak that up and down and play with that. But okay, I'm going to put that one to bed. If you got questions, please post your comments down below. I'll try to answer them as best I can and maybe point you to some other videos or articles or links out there that might help. Okay, let's see, moving on. We'll do number 5. It's getting a little warm in here. Number 5, what do I do with the battery in cold weather? So there's a few options in cold weather. One is the RV Industry Association. Their steering committee has recently recommended for RVs that the lithium iron phosphate batteries can be kept inside of RVs safely without venting or any other stuff like that. You could put this inside of your RV. You could sleep with it under your pillow if you wanted. And, you know, they say that's perfectly safe now. There's so few issues. There's no fires with these, really. I mean, you may find a couple of articles, but not for lithium iron phosphate. It's extremely rare. Some of the other ones you might see are like the lithium nickel, the lithium ion, the lithium manganese, and cobalt, and some of those other fancy chemical ones. But the iron phosphates are extremely rare to catch fire, cause venting, any of that kind of stuff. So the RVIA recommends that if you can configure it to be inside of your camper, they recommend you do that. Otherwise, if you can't do that, if it's not convenient, and you have it on the outside, you're going to have to come up with some kind of a heating solution, like an insulated pad. Something you can search for is silicone heating pad. Those are silicone sheets with wires run through them, and they'll run off at 12 volts. Do 12 volt silicone heating pad. You can get them on Amazon. They're not very expensive. Some of them will even have temperature relays built into them, or you can add a temperature relay onto it, and so it'll turn on and off as the temperatures are adjusting. Other than that, if it's extreme cold and you're laying up for the winter, you need to completely disconnect them. So, which kind of goes into the next one. How do I store the battery long term? That's question number 6. I'll just blend into that one. I'll segue into it. When you're storing these long term, you want to leave them at about 80%, and you want to completely disconnect them from your camper. You don't want to leave it connected, because any kind of flow or parasitic draw from some device like a clock radio or something could potentially kill that battery way sooner than you want to. So you want to hook it up to disconnect it with a hard switch, or just pull the terminal completely off, put it to the side, and just, that way there's no ions or electrons flowing in and out of the battery. So talking a little more into the long-term storage, some people say, can I leave it at 100%? Should I leave it, obviously don't leave it at 0%, but some people say, I heard that you're not supposed to leave it at 100%. It's not going to kill it to leave it at 100%, but generally below 90% is a little more healthy. These can last a really long time. They're extremely resilient. Lithium is it's phenomenal compared to what we used to have to deal with lead acid. So my suggestion, and on what we put on the front, is store at 75%. Actually, it's not on this one. It's on our plastic case one. Store at 75%, charge once every 6 months. That's just kind of a loose guide. If you leave it at 75%, you could leave it for a year and a half. They self-discharge at 1 to 2% per year. So if you take this down to say 80 amps and store it and you want to put it in the long-term storage, after 20 months, it's only going to be down to 40. It's only going to drop down to 40 amp hours. So you'll still have a lot of time left on that, and that's after 20 months. I mean, that's almost 2 years. If you're not using a battery more than once every 2 years, you might want to consider selling it, because something else could potentially be coming out by then. So yeah, long-term storage, 80%-ish. Try to charge it once a year, every 6 months to a year or so. Drain it down, charge it up. That's healthy for a battery. It's like a wheel. It doesn't like to stop rolling, Just keep something moving through it every once in a while. All right, with that, we go into the bonus question for my kayakers out there. We have a lot of people buying our batteries for kayaks, and one of the very common questions kayakers ask is, do I need a separate battery for my fish finder, depth finder, combo type devices? And the answer is maybe. I recommend get you one of the plastic case batteries. First, hook it up for your trolling motor. See if you're going to get chatter on your screen. Sometimes there's negative feedback, like lines and stuff that show up on your fish finders. And that has to do, I think, with the high frequencies of the motor somehow chattering on the line. I'm not sure exactly what's going on there. I've had maybe 20 customers ask that question in the last 3 months, and I've told all of them, just try the battery first, see how it goes. I've had 2 people come back and say they had chatter. one, I recommended putting one of those little ferrite or ferrule, I think they're called ferrite cores or coils around the wire going into their device. And I think that he didn't call back and he didn't buy the little battery. So I think that might have eliminated his problem. But I would say try it first, and if it doesn't, and if you do experience that feedback, then just go ahead and buy one of the smaller batteries. So yeah, with that, that's all I got. That is the most common questions we get from customers. Hopefully you got something out of this. I think I used all of my visual aids. So yeah, I think I covered everything. If you got any questions, like I said, comment down below. If you like, give it a thumbs up. We appreciate that. And click the bell icon. You get notified when we drop future videos. All right. Thanks for watching. We'll see you in the next one.